Hey everyone, welcome to another episode of TinkChat. Today our topic is how the oil and gas industry is looking to transform itself into a more efficient industry by adopting 3D printing.
Yeah.
So, full disclosure first, we are not oil and gas guys.
Yeah, we have no idea.
I think at best we are technology guys, understands kind of how different verticals are adopting the 3D printing tech.
Yeah.
And I do have some experience, not personally, but through our industrial designer, and seeing some of the stuff that he did, that he was working on, that he was taking an approach to with oil and gas, which predominantly was prototyping.
Yeah.
Plastic parts, fitting, and all that stuff.
Yeah.
But I think the oil and gas industry is actually transforming, and not just with 3D printing, digital fabrication as a whole. And so, we did some research. I mean, no, so more like Andy, you did some research, and we realized that there was actually quite a lot of changes coming.
Yeah.
Or proposed changes on the way.
Yeah.
Right. So one of the exciting things I think for anyone in the oil and gas industry is that supposedly these changes are they're gonna change the way that the revenue is generated, and it's gonna supposedly increase the revenue. And I guess from a business perspective, who doesn't like revenue?
Yeah.
Right?
I mean, we've seen from previous chats on different industries on how much additive manufacturing actually changes the whole business workflow if it's adopted in the right places, right?
Right. Yeah.
So honestly, I'm not surprised oil and gas is trying to get into this. There's a lot of reasons why, which we'll jump in a sec.
Yep.
Yeah, but as Eugene mentioned earlier, we both aren't really oil and gas people. I have no idea I didn't even know how these two industries will intersect. So I did a lot of digging, as Eugene said. Yeah.
Now I was gonna say one thing. What you guys don't realize is we have a board in front of us with a couple notes, and there is a note right in front of us that says "revenue to increase a lot" underscored by Andy.
Yeah.
And so, what is that a lot?
It's projected to be in by 2025 to be in the $1 billion ranges.
Is there a range, 5 to 35, 50 to 100 billion?
Some report says it's up to 32.5 billion. Some report says it's up to 6 billion. So there is a range between 6 to 30 billion dollars.
Right, some kind of variable in there for adoption, rate of adoption, and all that stuff. I mean, that's not a small amount of money by any means, right?
Yeah.
But, I mean, and I remember when you first shared that with me, I said, how are they doing that?
Yeah.
Why? I mean, I understand the why. But how? What are they looking to do? And when you started going through it, I'm like, okay, I can see this. I can see the check marks started coming off. So I mean, So how are they doing it? Well, what are they proposing that that they do? I suppose not we do. They do.
So let's talk about the benefits of additive manufacturing for the oil and gas industry. One thing I'm sure a lot of you know that oil and gas industries they work in really remote areas, right? So sometimes you see an oil rig in the middle of the ocean, right?
Yeah.
And one thing that they have to do is they have to carry a lot of spare parts in inventory with them.
Right.
And that's a huge sunk cost, right? All that money, capital put into
just
inventory that you probably don't even know, or you don't know when you need it.
Right.
And 3D printing will allow them to get rid of that inventory. Well, not get rid of it completely, but
so the inventory changes.
Yeah.
It changes from the individual parts and components, and it could be thousands, I suppose. Yeah. And it condenses it to pretty much one.
Yeah.
Assuming that the material type is the same, it condenses it to one, and the one inventory becomes powder material or the base material that the parts are going to be printed out of. And if it's powder metal, if it's whatever, that's their inventory. Yeah. And then it becomes I suppose a catalog of digital files that they print.
Yeah. So it eliminates all of that.
When we talk about one of the biggest advantages of 3D printing, that's one of them. I mean, we talk about in our last chat with regards to business adoption, we were talking about small and medium-sized businesses, right? And I mean, oil and gas is not a medium-sized business. They're a giant industry. And they've consolidated to the point where there's few players in it.
Yeah.
Right. But no business is going to leave efficiencies on the table if they can get it.
Yeah.
And if one of the biggest inefficiencies in that industry is the fact that there is a huge amount of capital just locked up in the business because they need it for parts. I mean, think about it. A downtime on an oil rig means millions of dollars lost per hour, right? And so it's in their best interest to get up and running as fast as possible. And I'm assuming though that there's also a certain amount of part synchronization between locations that they can do.
I think so, yeah.
Right? So, if one location finds out a better efficiency, they don't have to send this thing over to a machine shop then to make 10,000 pieces. They just send the digital file
to each
over
other.
And off to the races. And that's why I think this transformation in the 3D printing space, efficiency is more than just 3D printing, it's also digital fabrication.
Yeah.
So, reduced inventory, faster turnaround, just-in-time manufacturing.
That's
yeah, absolutely.
That's already a lot of savings right there.
Absolutely.
Just even faster turnaround, like flying parts out or anything like that.
Logistics, going to remote places. You can literally cut down logistics by or turnaround time by I'm assuming good like month and a half type of situation, and have turnaround be like 4 to 5 to 8 to maybe even a day, like 24 hours. That's still way faster.
That minimizes the downtime by quite a bit on oil rigs.
Yeah.
And it's actually pretty substantial, I would say.
Like I can see why they're saying the projected revenue increase, because I'm assuming that there has to be downtime. When machines go wrong, they go wrong. And when you're pumping out, literally, product, and you don't have the time to maintenance machines, and you want to keep up your production, something's going to go wrong eventually.
Yeah.
And if it goes down for like 6 to 8 weeks,
that's bad.
I think somebody's in trouble at that point, right?
Yeah, probably getting fired.
Yeah. We're talking about like oil and gas isn't using plastic parts. No. I don't think they're using plastic parts.
They shouldn't.
And because of the environment, because of the application, I'm assuming that the plastic parts are for testing, fitting, prototyping, and then that gets translated into the more end-use application. So the metal printing, the metal powder technologies, and then making end-use parts with those components, right? So, the cost efficiencies. So I don't think the cost, like we talked about this off camera before we jumped onto this, and I don't think the per part cost actually goes down. I think the per part cost goes up, at least in this meantime. But because of the potential savings on the turnaround time,
in the long run,
and
I would say,
how they can keep their units up and running, production units up and running quicker for longer.
It kind of covers that.
That covers that increased cost, and that increased cost could be like a $70 part could literally turn into a $400 part.
Yeah.
But if that $400 part generates $1 million worth of oil, then that increase doesn't matter. It's like it's a super small amount
compared to the bigger
the
picture.
downtime, right? Yeah. So like we don't know the inner workings. Like we did not dive into like an oil and gas company exploring.
Yeah.
We did a little bit.
We did.
But we didn't look at their books. We didn't do any of that. Yeah. But logically speaking, that makes a lot of sense, right? And we're just talking about oil, not so much like mining. Like mining is a totally different thing. Yeah. And I think it kind of works around the same space. Yeah. Remote locations, needing of parts, just-in-time manufacturing, all that stuff. And then there's the innovation stuff that comes up on top.
The prototyping.
Yeah.
We talked about in previous episodes, in every industry, 3D printing is used for prototyping to give the industry a more of an edge. These new complex geometries that these 3D printers can print, they're stronger, they're lighter, they're just less time to make it.
Or they assemble complex parts together as a singular manufactured printed object. Yeah. And now you have less complexity for assembly, easier maintenance. Yeah. all those benefits that come out
And
of it.
it's just if you look at it back then, how people would usually do it, they design it, draw it on paper, and then they send it to the machine shop before they actually know whether or not the part works.
They probably CAD it up somewhere in there as well.
Yeah,
Yeah.
but they would never know whether or not it works yet.
Until they
So-
get the final part.
Yeah.
That's
So
right.
now it's also another advantage is they get to print out the part in, let's say, 2 days,
Yep.
test fit it already into the tool that it needs before actually making that leap
Yeah.
to committing to like 500,000 pieces.
Yeah.
for
So to give people a sense, I mean, when we first got started as a hardware company,
Yep.
we were looking for a machine shop locally here in Vancouver.
Yep.
And we had a shop that also worked on oil and gas parts.
Mm-hmm.
And we realized the turnaround time was going to be 2 to 3 weeks,
Wow.
right? I mean, sure enough, we probably could have gone to another machine
Yeah.
shop, but the oil and gas industry, I believe, works a bit in that 2 to 3 week turnaround time.
Mm-hmm.
I mean, the tight tolerances that they need,
Yeah.
the finish that they need, the fit, all of that requires time.
Mm-hmm.
And so 2 to 3 weeks just for a prototype, that's a heck of a long time,
Yeah.
right? I mean, sure, a 3D printer, like a 3D printer that can do what they're looking for is in the realms of $200,000-300,000
Yeah.
at a minimum. And on top of that, you probably want to have some tighter tolerances. So, you're looking at maybe 4 to 5 days of time frame just to get that first prototype. But 4 to 5 days is still better than 2 to 3 weeks, right? And so, like, the prototyping part, the complexity simplification, okay, that's an oxymoron. But that's what it really is, right? Taking complex geometries, combining them into a singular thing so that you don't have to have fasteners.
Yeah.
You don't have to worry about things that leak and gaskets.
Yeah.
You can then worry about things like maintenance and ease of maintenance and
Yeah.
ease of access,
Yeah,
right? I'm just
exactly.
counting them all in my
Yeah.
hands. And then you add in everything on top of that, the efficiencies, the tuning that can be done.
Yeah.
So like if a part needs to move more object, then you can design it to move more object because now you can manufacture this totally differently than if you could do subtractive manufacturing. Okay? So I think, like if I was in oil and gas
Mm-hmm.
as a technician, this is exciting.
Yeah.
If I was in oil and gas and I'm looking at this thing from the perspective of the manual labor, this is exciting.
Yeah.
Because I'm not worrying about, like if I'm a rig operator, I'm not worrying about like, oh my God, I need to have people on hand, and then I need to have inventory on hand, and I need to make sure everything's up and running. Like this gives flexibility. Like
Also-
this is like absolute flexibility.
Yeah. And also, I think it takes a load off the stress from your shoulders if you're a technician.
Oh, you know what? I think if a rig goes down, that's stressful. Like I can't
Well,
imagine.
I mean, not even that. It's just what happened if they designed a new part and it didn't work?
Well, I think that they would test fit that before they.
I mean that's only once they had a 3D
That's right.
printer, but
That's right.
back then in traditional
That's right.
manufacturing ways, stressful, right? You're waiting 4 weeks
That's
for
right.
a part that doesn't work, and then you fit in, and then like, oh, we had a downtime.
I'm
And
99% sure that most of those remote places that are doing like exploration,
Yeah.
oil and gas, they have their own machine shop of sorts.
Yeah.
They have a machinist on hand of sorts, so that when they get a part,
Yeah.
and if it doesn't go well, they can machine it to a certain degree on hand.
Oh,
Like
okay,
I can't imagine where the part goes there and then it's like, oh my God, the holes are in the wrong places,
Yeah,
and then they gotta send it
okay.
back and wait for 2 more
Okay.
weeks. Like they can do certain amounts of work,
Yeah.
but they can't do the fine amounts of work, like the super detailed stuff.
Yeah.
Because that's not what the facilities are for.
Huh.
The more capitalized companies, I'm pretty sure, will have a pretty good machine shop on site.
Well, I've never been on an oil rig, so I have no idea
Yeah.
whether or not that's true. But
but-
I'm just gonna take Eugene's word for it.
I'm just logically thinking my
Yeah.
way through this, right? But I can imagine if a system can be made where the flexibility for parts exists, and they have the ability to fine tune the tolerances, all in one unit,
It would make sense.
that will be placed in every single oil and gas rig facility,
Yeah.
like or close enough to,
Mm-hmm.
right? And like, sure enough, we found one article talking just about something along those lines, right? And we'll go into that. But before that, there needs to be pretty big changes that comes to this
in the
industry.
Yeah.
We mentioned a couple. Like, there is the question about how does the digital inventory get managed?
Yeah.
Right.
Or how does it even start?
Yeah. Is it
First,
is it a centralized thing between companies? Is it
Yeah.
a centralized thing only in companies? Like it's an intranet type of inventory system, or can like a competitor also get the same part as me?
Yeah.
I mean, surely I suppose that could work.
I mean, it will only make sense that two competitors use the same part. It's easier on the manufacturing process, I'm guessing.
It's like a Home Depot.
Yeah, it's like interchangeable. Well, it makes sense in my head that way.
Yeah.
But whether or not it makes sense for them to give up
Their IP.
their IP, because all these oil and gas companies, they all have their own IPs.
Right.
And
IP control, right?
Yeah.
A digital file, signatures, checking. What if that file gets leaked? Because if it gets leaked, their competitor gets a hold of it. So there's that whole complexity that needs to happen.
Yeah.
And then there is the transformation of the employees.
Yeah.
Because do you need a person on site that can operate the machine? Do you need a person on site that can finish the machine, like finish the parts?
Yeah.
Like there will be a shift in the skill sets required. Yeah. And then do you need a person on site, or do you need people that then can do CAD work to improve the product?
Yeah.
And so you get this feedback loop of design, iteration, testing. Like, I don't know how much of that goes on in the oil and gas. Surely there's a certain amount of that for sure, right? Well, but because the facility is so close to the actual site now, like that loop can be like super accelerated, and that's an interesting element. That's
and then
super interesting.
There's also one thing that I think that they have to look at is if they do have 3D printing in every site, who will be the actual person to say it passes the quality check? Because it's gonna range from different sites, right?
Yeah,
it's not gonna be the same.
I know that for sure that there's on-site mechanical like guys that will be able to sign off on the part.
Yeah.
Right. But you do require like typically when you send a part to a machine shop, you give them all the tolerances, you give them all that stuff, you get the part back, and then you measure all the tolerances that you're looking for, and then you check it off, right? That process will still exist.
Yeah.
That won't. I don't think that will change because otherwise you lose the quality assurance of the part. But then that now becomes an on-site type of situation.
Yeah.
Right. And I mean, it is an on-site type of situation right now.
Yeah.
It just becomes way more demanding because the parts are literally flying off. I mean, not literally, but they're flying off faster than like a person can say, I need that part tomorrow. And assuming that the part actually takes 24 hours sprint, you will literally get it in 24 hours. And so now you've got this extra layer of speed, and speed condenses things. Like it condenses stress. Yeah. And so in a shorter amount of time frame, you have to do more to get it back up and running. But once it gets back up and running, you're good. Yeah. So yeah, like absolutely, right? It's like staff training is going to be pretty big. What happens if that one mechanical guy that can run the 3D printer like gets sick?
Well, I'm sure he's still going to be on an oil rig.
I mean, what if you had to fly him out?
Oh, then I guess.
I mean, then you still like there needs to be additional redundancies put in place, right? Yeah. So things will change. Staff training will change. Redundancies will be put in place, and like that's going to be a pretty wild change. Yeah. Like everything gets outsourced. Now everything gets vertically integrated. Yeah. Very different business when things start to vertically integrate.
Yeah. I guess they just have to think about this to move forward, right?
Yeah. Well, I mean, we wrote it down as the needs for that to happen.
Yeah. Yeah.
So, absolutely. So, like, who's doing this? Like, who is starting this trend of changes or chain of changes?
Well, one of the companies, it's pretty big. It's Chervron. I'm sure everyone knows who Chervron is. One of the many gas stations that we have
in Canada.
Yeah. I think they have different types of names in the States. I don't remember them. But they actually went into a partnership with someone called the Sulzer. I don't know if I'm saying their name right. And this partnership is where Sulzer is going to be using these hybrid additive manufacturing methods to produce stuff for Chervron.
Right. And so for those that are wondering what these hybrid systems look like, Andy and I covered it in
Yeah.
one of the episodes.
Yeah.
And so these systems are where they integrate 3D printers, metal 3D printers, into that of a traditional subtractive manufacturing system. And so what they'll typically do is they'll over extrude, over deposit the shape of what it is that they want, providing no waste to subtractive manufacturing, and then they'll go in with your typical end mill on a CNC and bring the tolerances back to where the original part is supposed to be at. Saving material, saving some time, and then still getting the end results just as good as if it was.
Well, I guess that answers my question. Before in the last episode where I was like, I don't know who would use this technology because I was like, it seems kind of redundant, right?
Yeah.
But now I have my answer.
It like I think we see 3D printing as direct to, and that's what we mentioned, direct to object, and no need for tight tolerances. We can design enough tolerances in our parts for where we want it to work. Yeah. But when you're dealing with like microns of tolerances, when I say microns, like 1 to 5 microns, the FDM, so the desktop 3D printer technology, isn't good enough for that. And even some of the other ones like resin and powder isn't good enough for that. So you do need to tighten the tolerances via a post-processing method like a CNC or whatnot. Yeah.
So essentially this partnership, Sulzer is helping Chervron minimize the lead time. So they're getting our parts a lot faster. Yeah. And one of the things that they're creating for them is pump impellers. And in the article, it says they were expecting, in like traditional manufacturing ways, it was like up to like 40, 60 weeks.
Yeah.
And
40,
now
4 to 6 weeks.
4 to 6 weeks.
That's right. 4 to 6 weeks.
Something like that. Minimized to just 3 or 4 days.
Right.
And that's a huge difference.
So the pump impeller situation is quite close to me in my previous life. Oh. And like an impeller design is pretty simple. It just moves liquid, and you can actually do a lot of complex impeller designs to give the pump more head pressure. You probably don't know what that means, but it means if it needs to pump liquid upwards, it has the pressure to move that liquid up to a certain place.
Doesn't it just spin faster?
No, it doesn't need to. It could have more pressure to do that. It needs to be able to, like, same goes for fan design. Certain fans are able to move more air, but they can't hold pressure.
Okay.
So in that similar fashion, like I'm geeking out right now. In that similar fashion, impellers are the same. Yeah. There's impellers that can spin faster to move more liquid, but if it needs to move liquid up vertically, then you end up with a situation where that pressure that's coming down will prevent the liquid from moving up. So then you end up you can only pump water so hot, liquid so hot. I see. There we go. Okay.
I just think of them as turbines.
They kind of are. They really are. But I mean, that's an absolutely great use because you can make shapes and optimize for an impeller that you actually can't machine. Yeah. And so like taking such a simple part and improving on it to give additional efficiencies, like that's kind of genius in my opinion.
Well, I guess they did the right thing going into a partnership.
Yeah. Yeah.
So that's what Chervron and Sulzer is doing. Another company I'm sure everyone's very familiar with is Shell. Shell, the gas station as well. They're actually using 3D printing in their business as well, mostly laser sintering instead of the hybrid additive manufacturing.
Powder-based technology. Yeah.
So what they were saying is traditional manufacturing processes, which is CNC, it's too wasteful.
Okay.
And so they went for laser sintering technology, which is a lot more cost effective because even after you're done with the part, you can still reuse the metal powders.
Right.
And that saves a lot.
Yeah.
And
let's provide a bit of clarity as to why subtractive manufacturing. For those that are watching that aren't familiar with manufacturing, so subtractive manufacturing takes a singular block and it removes objects. Sorry, it removes material until you're left with the object you're looking for, which means all those little shavings that come off, they then get recycled later and then rebuilt back into another block of sorts. Or some people just simply like throw it away. But when you have a lot of shavings, you typically recycle them. Whereas 3D printing, you start with the material, in this case, a powder bed, and you only use the material that you fuse together, for lack of better words. And then all the surplus powder material then can be reconstituted, mixed with additional virgin material, and then reused as a batch of material for the next print. So you can keep recycling that to a certain degree, but you can't recycle it indefinitely. So in that sense, you like both of them are recycling. But one of them is just a way easier process of recycling than the other.
Well, you don't have to. First of all, you don't have to bring it out to someone else that can actually make the whole block of.
Smelt it down. Cast it into a block of aluminum and go.
So that's a lot faster. That's one of the main reasons why they chose this technology.
That makes sense. It's also a tighter tolerance technology as well. Just a fundamental. Whereas the hybrid technology over deposits. So like you're printing a cube, you want a cube that is, I'm going to go 4 inches by 4 inches by 4 inches. That technology will make a cube that is like 4.25 inches by 4.25 and by some odd number. And then
they shave it down.
The CNC comes in and shaves it down to the 4-inch cube. Whereas the sintering technology will get you like 4.01.
It's pretty close.
It's pretty close. And then if they choose to want to get that tolerance even tighter, then they can. I can't believe I just used inches.
Because 3D printers never use inches.
That's fine.
Everything's in millimeters.
So it was my understanding that they took these parts that they sintered. So SLS, metal sintering. And they used them for functional prototypes. So it was to test fit, form, and functionality. And then the idea was to move it over to end use. I mean, that makes sense, right? So this is more of a trial. I believe this is more like when we read the article, it felt like it was more of a trial run.
We don't know how. It never actually really said how many 3D printed parts are on their oil rigs now. So we don't know if it's actually like functional wise. Is it actually like at the site? But we know that they are test fitting it, prototyping with it, and
select places probably.
To make sure that they can actually increase these efficiency, make parts stronger, and stuff like that.
Design optimizations. That makes it like anytime when we're talking about design optimization, and this theme will keep coming back. And like every episode we talk about a specific industry, it will always cover. I'm like 99% sure of this. Design optimization. It will almost always talk about efficiencies with regards to manufacturing, and it will probably talk about increasing complexity for shapes. Because
that's what 3. Where were we, Eugene?
I think we're actually just about to wrap up. So like we were talking about how like most of these episodes talking about different verticals, efficiencies and complexity and all that stuff comes in various different ways, right? Different forms. And like 3D printing brings a lot of that to manufacturing industries in particular. So like anything that's physically making something will always be looking for those things. Because like every company is looking for efficiency. Better efficiency, more profit. In this case, better efficiency, more profit. But that may be different when we start to get into service businesses that are looking to bring this technology to their customers. And when I say service businesses, I don't mean like service bureaus where you're 3D printing pieces for people. That's already there. I'm talking about businesses that are looking to leverage 3D printing as a way to be more engaged with their customers. So that happens, but at a much smaller fraction. But that's another topic altogether. So So I mean, I just wanted to point out that there's going to be consistencies across the board, and like those three things that we talked about are
Well, that's
always
what-
pretty much going to be there.
Yeah, that's what 3D printers are all about, right?
Yeah.
Well, unless there's another use for it that we haven't found out.
I don't know.
But we don't. Yeah.
Yeah.
Those are main points of so far of adapting 3D printers or additive manufacturing in general into your business. So those are things that if you want to look at, you should consider then.
Yeah,
right?
and it definitely requires big understanding on technical skills.
Yeah.
So, what is required with regards to your team that can do that. I mean, we covered in some of that last episode. But there's a lot to consider.
Yeah.
And these, like, it's evident that industries are considering, but even then, there's a lot to consider.
Well, they're considering and they're changing. They're pivoting.
Yeah, just gotta remember though, when any industry makes a change, it's a big impact.
It is.
It's a big impact because there's not 100% certainty unless they start trying about the returns they're gonna get.
Yeah.
Like theoretically speaking, all this makes a lot of sense.
Yeah.
But that transition and making that transition work long term, that's the hard part.
It's a lot of work.
That's a lot. Yeah. Like, you know what they say about don't fix what's not broken,
True.
right?
Yeah.
And so the system isn't broken,
It isn't.
but it's just not efficient.
It's not tuned.
Yeah.
Yeah. So which is why we're all those reports are saying gas and oil industries revenue is going to go up by 2025.
Yeah.
By a lot. A lot, because we don't know the actual number. Yeah. So I guess that wraps up this episode for oil and gas. A lot of changes.
Yeah.
For them.
Well, a lot of projected changes.
Yeah.
It's going to be interesting to see. I mean, also you got to keep in mind we're moving over to like electrification.
Yeah, which is why it matters to them so much
For
right now
efficiencies.
to actually, for efficiency to maximize the revenue, right?
Yeah. Yeah.
Yeah.
It's not going to be a tomorrow thing.
Yeah.
It won't be.
They still have a couple decades, I think.
I give it a little less than that. Depends on how hard we push as a society for EV.
We're pushing pretty hard.
Yeah, I think so. Okay.
Well, yeah. Anyway, that's the end of this episode. So remember to subscribe with the button down there, and also click the bell button as well. And if you don't have time to watch us, you can listen to us on Spotify or Anchor, and hopefully, you'll be able to listen
Enjoy
to
the
our
content.
chat.
Yeah.
Enjoy our context. And we also actually just changed our setup a bit. We changed our mics. So if you guys have any opinions, whether or not our audio is better, let us know in the comments below.
Yeah. Or if there's a specific industry that you want us to dig into,
Yeah.
a topic that you guys want us to dig into, like all these TinkChat segments
Yeah.
are almost to a certain degree a industry research that we're
Yeah.
doing for both ourselves
Yeah.
as we start to develop out more of the skills content. And we'd love to know what you guys are interested in. So leave a comment in that area. Oh, sorry, leave it in the comments. Like you're
Yeah.
way better at this outro thing than I am. So go for it.
Yeah. Well, remember, as Eugene said, leave it in the comments below, and we'll catch you next time.
Okay.
Okay.
Cool.
Bye.
Bye.